Hey y'all, welcome to 4.5. This is banking applications of the log and exponential functions that we've been studying. This is more exponential than log in terms of the way it's started. So when working with banking problems, we know that interest rate in terms of savings type accounts adds money to your account. On a loan, it adds money to the amount you owe, and that's the price you pay for paying it out. So the interest rate could be compounded continuously or at a specific interval. So compounded is how many times a year interest is added to the account. So if it's being compounded continuously, we use this formula. A equals P times E to the R times T. For compounded on a specific interval, we'll use a little bit different formula. A equals P times 1 plus R over N, all to the power of N times T. And let's talk about what all of those letters mean. A is the amount after. A, amount after. A, amount after. Okay? P is the principal or the initial amount. That's the amount you put into the account. P is what you put into the account. R is the interest rate. And we'll have to convert that into decimal form. N is the number of times it's compounded per year. And T is time. Typically in banking problems, number of years. Now, the number of times we're compounded per year, this little chart over here on the side is going to give us some options here. Compounded annually means 1 time per year. N would equal 1. Semi-annually is 2. Quarterly is once every quarter of a year. It's 4 quarters in a whole. So that's 4 times a year. Monthly, 12 months in a year. Okay, I'm going to skip to weekly because there are 52 weeks in a year. Bi-weekly means every 2 weeks. So that's 26. Daily would be 365. And if we are compounding continuously, we would be compounding an infinite number of times per year. That's why we have to go to a different formula, so we can't really plug infinity into a formula. So let's look at this first example. Okay, Sam is investing $8,000 into an account that earns 2% annual interest. Find the amount in the account after 5 years with each of these types of compounding. So A is what we're being asked to find. Find the amount after. A is the amount after. P is what we put into the account, the principal. It's the 8,000. R, 2% as a decimal, is 0.02. N is the number of times compounded per year, and that's going to vary. T is 5 years. So we will plug all of this in. So if we are compounding annually, N is 1. So using that compound interest formula, we'll do 8,000 times 1 plus R, 0.02 over N, which is 1, to the N times T, so that would be 1 times 5. It's definitely a calculator lesson. I'm going demonstrate this in Desmos, but you can do this on the calculator, handheld calculator as well. 8,000, open a parentheses, 1 plus 0.02 over 1, get out of the fraction, close the parentheses, raise to the power of 1 times, on Desmos you need parentheses on the power to put an operation in it, so 1 times 5. And here's our number, 8823.65. This is money, so we're going to round to the nearest cent, dollars and cents. So we'll round to 2 decimal places. So when we are compounding annually, that is $8,832.65. Scoot you over just a little bit. Okay. Now, if we compound semi-annually, that's 2 times a year. So in the calculator, you can just change this 1 to a 2. It's really easy to do on Desmos. You can do it on the calculator as well. Just type over the 1 and make it a 2. And there's your result. 8836.98 when we round. So 8836.98. So we see that got us a little more money. That got us a little more money because we added interest twice a year instead of just once a year. So the interest we added the first time helps the account earn even more interest the next time. For compounding quarterly, that N is 4. So we're going to compound 4 times a year. Change that number to 4. And we see our number went up again, 8839.16. 8839.16. So again, we've gone up a little more. When we are compounding monthly, that N is 12. 12 times a year. Monthly would be 12 times a year. So change these to 12s. Not 412, just 12. And we have 8840.63. So we're getting a little bit more money here every time. Okay, compounding bi-weekly, that's 26 times in a year, every other week, every 2 weeks. So change these 12s to 26. Once again, not 126, just 26. And we have just a little bit more money now, 8841.03. 8841.03. We didn't go up by as much, but we're still getting a little bit bigger. If we compound weekly, so we're adding money to this account every single week, that would be 52 times a year. So I'm going to make those 26s into 52s. And we have 8841.20. So we didn't gain just a whole lot there, but we did gain some. What was it? 8841.20. If we compound daily, that is 365 times in a year. Whoops. So 365 times a year, 8841.34. So 8841.34. If we notice each time, we are getting more and more money. but the amount we increase by gets less and less. So the values are getting closer together, but they're still getting bigger. Okay, if we had to estimate, does this amount appear to be approaching a specific value? It's getting really close to 8841.30 something, maybe 36. It's just a little bit of an estimate, okay? It's a guess. It's getting close. What this is actually approaching is the compounding continuously amount. Compounding continuously, A equals P times E to the power of RT. So that would be the 8,000 we started with times E to the R, 0.02, times T, which is 5. So 8,000, no, don't zoom, 8,000 times E. On Desmos, to get E, go to the ABC keyboard, use the E button, go back to the number keyboard, to the power of, you'll need a parentheses, 0.02 times 5, close that parentheses, and this is the dollar amount if we could compound literally every second of every day. So 8841.37. 8841.37. So if we were to compound more and more times per year, it would eventually top out at 8841.37. And if you really want to, you can check that by making the number of compounds here as big as possible. If I make that 500 times a year, we're at 35 cents. If I make that 5,000 times a year, we're at that 37 cents. If I make that 10,000 times a year, there's only so big this can get. Okay, and we're still at that 37 cents. Okay, so that is our compounding continuously value.